Good day everyone, my name is CHENG. My teammates YONG, CHOON, CHUN and Ji. Our topic is designing a network topologies. So basically we will touch about virtual VLAN and also security topologies. So let's go.
Virtual Local Area Network, or we can call as VLANs. VLAN allow the computer, server of other network devices logically connected, regardless of the physical location. A VLAN is a set of LAN devices that belong to an administrative group. VLAN is extremely flexible, and it allows a large flat switch-based network to be divided into separate broadcast domains. So given the situation is that there are 3 departments, and the PCs of the department is placed at a random floor, and all of them connect to one switch. And they will have the network traffic problems, like the accounting will see the shipping networks. So the network administrator should separate the network. So using a VLAN cable switch, we can create the VLANs on it without the physical change. So you can see that there are 3 VLANs will be created for each department, so the accounting will not see the shipping networks. So the reason of using VLAN is that it helps to traffic management and improve the security and make the network simpler.
Virtual Local Area Network is a collection of devices or network nodes that communicate with one another as if they met up with single LAN. In a technical sense, a segment is separated from the rest of the LAN by a bridge, router, or switch, and is typically used for a particular department. When a workstation broadcasts packets, they reach all other workstations on the VLAN but none outside it, reduce the incidence of collisions and decrease the number of network resources wasted by acting as LAN segment. Data packets sent from a workstation in a segment are transferred by a bridge or switch, which will not forward collisions but will send on broadcast to every network devices. Local area network connects network devices in such a way that personal computers and workstations can share data, tools, and programs. The group of computers and devices are connected together by a switch or stack of switches using a private addressing scheme as defined as the TCP/IP protocol. Private addresses are unique in relation to other computers on the local network. Routers are found at the boundary of a LAN, connecting them to the larger one. The main difference between local area network and virtual local area network is that local area network work on single broadcast domain, but virtual local area network works on multiple broadcast domain, and in local network, packet is advertised to each devices, while in virtual local area network, package is sent to specific broadcast domain. A little summary for VLAN and LAN. LAN stands for local area network, while VLAN stands for virtual local area network. The cost of local area network is high, but the cost of virtual local area network is less. The latency of LAN is high, while the latency of VLAN is low. The devices which are used in LAN are hubs, routers, and switch, but the devices which are used in VLAN are bridge and switch. In local area network, the packet is advertised to each devices, but in virtual local area network, packet is sent to specific broadcast domain.
Okay, now we will move to a switch with VLAN. Before that, I will talk about without VLAN. Okay. In the figure, you can see there are 2 networks, which is network A and network B. Switch A and switch B, there are no physical connection. Example, when station A1 want to send traffic to station B1, it will not allow because there are no physical connection between switch A and switch B. Station A1 only allowed to send the traffic, any traffic, to station A2 and A3, which is the station in network A. Now we will move to with a VLAN. Okay, in the figure we can see there is only 1 switches and 6 stations are linked are connected into 1 switch. So station A A1, A2, and A3 they are in VLAN A. Station B1, B2, B3 they are in VLAN B. So it is the same as the previous example. When station A1 want to send any traffic to station B1 or B2 and B3, it will not allow because they are different VLAN. Station A1 are only allowed to send traffic to A2 and station A2 and A3, which is station in VLAN A. That's all for me. Thank you.
VLAN span switches. How the VLAN span switches working? Based on the figure, we can see switch A to switch B take a same interconnection path. Both switches has been configured to recognize VLAN A and VLAN B. They can exchange frame across the interconnection link, and the recipient switch can determine the VLAN into which those frames should be sent by examining the VLAN tag. The link between two switches, we call it trunk link or trunk. Trunk allows the network designer to stitch together which VLAN and that span multiple switches. A major design consideration is determine the scope of each VLAN and how many switches it should span.
WLAN and VLAN. A wireless LAN WLAN is often implemented as a VLAN. Place multiple access points can give the user the ability to roam freely. So we need to put all the users in the same IP subnet and the same VLAN to make sure the user can roam. It is because the device moves from subnet to subnet must accrue a new IP address. So keeping all the wireless clients in their own subnet can make it easier to set up the traffic filter to protect the wired network from the wireless user.
Workstation to router communication. Workstation in a campus network must have access to router to reach the remote service. This should implement the redundancy as it is important. Next page describes the method for workstation to learn about routers and redundancy features that guarantee a workstation can reach a router. So we have three methods. First is for CRP, where the workstation no need to be configured with the address of a router, but never been standardized and easier for attacker to reach another network, so it is not suggested. Second is Internet Control Message Protocol, ICMP. Each router periodically multicasts an ICMP router advertisement package announcing the IP address of its interface every 7 to 10 minutes. Or it will multicast an ICMP router solicitation package to ask for immediate advertisement when startup, so no need to wait the 7 to 10 minutes. The disadvantage is that workstation does not always use the most faster method to reach the remote station, where we'll have an extra hook problem, so it's not suggested also. Last is default gateway. Configuration can be done on each workstation or at DHCP server that supports many workstations, but it requires a single point of failure because many implementations keep track of only one default gateway. But this can be solved using the HSRP. So it's suggested to use the default gateway using the HSRP.
Hot Standby Router Protocol. Also we call it HSRP. HSRP is way for an IP workstation to keep communicating on an internet network even if its default gateway become unavailable. HSRP work by creating a virtual router, also can call a phantom router. How the HSRP work? The virtual router has its own IP and MAC address. Each workstation is configured to use the virtual router as its default gateway. When a workstation broadcasts an ARP frame to find its default gateway, the active HSRP router responds with the virtual router MAC address. If the active router goes offline, a standby router takes over as active router continue the delivery of workstation packet. The change is transparent to the workstation. Another major design consideration is the capacity of trunk links.
Multi-homing the internet connection. Multi-homing refers to provide more than one connection for a system to access and offer the network service. For example, a server has more than one network layer address. Content delivery network can multi-home application layer data and service. An enterprise network can be multi-home to the internet in many different ways, but it depends on the customer goals. Multi-homing the internet connection can be challenging if a customer goals are complex. Therefore, simplify the goal to ensure the ease of implementation, scalability, availability, and the affordability.
The arrangement of hardware devices on a network with respect to internal security requirements and needs for public access. For example, an internet order firm will need web servers that can be accessed by the public for placing orders. In turn, the web servers will need access to internal database servers, and internal users will need access to the various servers and possibly to the internet. The acronym DMZ originates from the military term demilitarized zone. It refers to an area declared as a buffer between two sides in a war. In IT security, it is used to refer to what is essentially a buffer between the internet and the internal network. It's separated by an outer firewall on the internet-facing side of the DMZ and an inner firewall on the internal network side of the DMZ. Any devices placed within the DMZ are accessible from both the internet and the internal network. There is no communication, however, from the internet directly through the DMZ to the internal network. Any system placed in the DMZ must be configured to the highest level of security possible, with the caveat that they must still be able to perform the role for which they are intended. This system should always be considered to be compromised and must never be given direct and unrestricted access to the inner network. Servers typically placed in the DMZ are web, FTP, email, and remote access servers.